Hey everyone, welcome back for another deep dive. Today, we're going to be diving into something that sounds kind of simple on the surface, sequences. But before you start thinking back to, those math class nightmares with numbers in a line, we're actually talking about the kind of sequences that make up, well, language, stock prices, even the weather.
It's true. Sequences are everywhere once you start to see them.
Right, and we've got this super interesting section from a deep learning textbook to guide us. And it all starts with this question. You ready for this? Can we actually predict the future just by looking at the past?
Ooh, that's a big one.
I know, right? And the book uses this example of a stock trader, which I just love because who hasn't fantasized about, like, cracking the stock market code?
Oh, yeah, that'd be nice.
Right. You've got all this historical data, prices going all over the place, up, down, and you're trying to figure out, is this thing going to go up tomorrow or is it going to totally tank? It's a real nail biter.
It really is, and that's where things get really interesting. Like, imagine you're that trader, right? You're staring at all these charts, you're trying to make sense of it all. What tools do you even have?
Well, they've got their fancy charts, algorithms.
Yeah,
It's practically a whole different language, right?
exactly. It's like learning to read the market's mind. And one of the most important tools in their arsenal is this thing called an autoregressive model.
Okay, an autoregressive model, breaking it down.
So think of it like this. Instead of just looking at, a bunch of random factors all at once, autoregressive models actually use past values in a sequence to try to predict what's coming next. So it's kind of like saying, all right, let's see, this stock has gone up the past 3 days in a row.
Is it going to keep going up?
Yeah, exactly. Or is it about to take a nosedive?
So it's like our brains are trying to finish the sentence, but for the stock market.
You got it. But, and this is a big but, the further out you try to predict, the harder it gets.
Makes sense. It's like a weather forecast. They can tell you what tomorrow's weather will be like, maybe even the next day.
Right. But good luck getting an accurate forecast for next week.
Forget about it.
Exactly. And it's the same with this kind of modeling, with sequence modeling. Even tiny little errors in predicting tomorrow's stock price, they can turn into huge differences down the line, like a week, a month, even a year later.
Oh, no. So you're saying my get-rich-quick scheme of
Yeah.
predicting the stock market is flawed.
Well, let's just say it's a tad optimistic.
Okay.
And this is where understanding this idea of stationary dynamics comes in.
Stationary dynamics. Sounds complicated.
It sounds way more complicated than it actually is. It's really just a fancy way of saying that we're assuming the underlying rules that sort of govern the sequence, they're going to stay pretty consistent over time.
Okay, so like in our stock market example, we're assuming the stock market doesn't just like completely transform overnight.
Exactly.
There's some method to the madness, even if it feels totally random.
You got it. Things like economic growth or interest rates, even, just general investor sentiment. Those fundamental things that actually influence stock prices, they tend to be pretty stable, even if the prices themselves are all over the place.
Okay, that makes a lot more sense. But if predicting the stock market is so tricky, where else do we see these like sequence modeling superpowers in action?
Well, have you ever noticed how sometimes you're listening to someone talk and you can almost predict what they're going to say next?
Yeah, all the time. Especially if it's like my husband telling the same story he's told 1,000,000 times.
That's a perfect example of your brain acting like a sequence model. It's using what you know about language, about context, even your husband's speaking style, to anticipate what's coming next. And you know what? Language models actually work in a surprisingly similar way.
Okay, so you're saying my brain is basically like a walking, talking ChatGPT. That's both.
Yeah.
Kind of terrifying and also kind of amazing. But seriously, how does that even work?
So it all comes back to this idea of autoregression, just like we were talking about with the stock market.
Okay.
Language models are trained on tons and tons of text data, and they learn to predict the next word in a sequence, but just based on the words that came before it. Like, think about those autofill features you see on your phone or in your email.
Yeah.
It's always trying to guess what you're going to type next, just from how you've written before.
Okay, that makes sense. But language is so nuanced. There are so many layers to it. Are these models really able to capture all of that, all the subtle meanings?
It's a great question, and honestly, you'd be surprised by how much they can pick up on, even with a pretty simplified approach. See, even with all that data, language models often use this thing called the Markov assumption.
Oh, what now?
The Markov assumption. It's like saying that we only need to look back a certain distance, kind of like a window of past information, to make a pretty good guess about what comes next.
So they're not like Analyzing the entire dictionary every time they make a prediction.
Exactly. Even the most cutting-edge language models, they might only be looking at a few thousand words of context at a time.
Wow.
It seems kind of crazy, right? Like, imagine trying to write a novel, but you could only remember the last few thousand words you wrote.
Yeah, that would be tough.
Right. But it turns out it's actually really effective. And this whole idea of sequence modeling, it's not just for language either. It pops up in all kinds of cool areas, like predicting melodies and music, or even understanding DNA sequences.
Wow, that's wild. But sticking with language for a second, there's something I've always wondered about, like, why do we always focus on predicting language from left to right?
Interesting.
Couldn't you technically, like, predict a sentence in any order?
You absolutely could. You could go backwards, you could start in the middle, the possibilities are kind of endless. But think about how we actually read and understand language, at least in English and a lot of other languages too. It's a left to right flow.
Right.
And it just so happens that training these language models to predict words in the order that they actually appear, well, it seems to work a lot better.
So there's a reason why we don't read books back to front.
Makes you wonder about those who do, though, right?
Yeah.
Uh,
But I'm guessing it's not always, like, smooth sailing with these predictions, is it?
Not always smooth sailing, no. Remember how we were talking about those stock market predictions and how they kind of get less reliable the further out you try to look?
Oh, yeah, definitely.
So there's this really cool experiment in the textbook that shows this perfectly. Imagine they were trying to, train a model to predict this wave-like pattern, something that goes up and down predictably, but with a little bit of randomness mixed in, just to make it like real-world data.
Okay, so I'm picturing, like, a heartbeat monitor.
Or
Maybe the ocean tide going in and out.
You got it. Those are great examples. So when they tried to just predict one step ahead, just the very next little bit, the model actually did a really good job. Like, it was basically riding the wave, anticipating that next rise or fall. But, and here's where it gets interesting, as soon as they tried to predict multiple steps at once, further into the future,
You crashed and burned.
pretty much, the
Yeah.
predictions went totally haywire.
So it's like you're trying to predict the tide, like, a whole week from now, just based on how it looks right now.
Yeah.
It's an impossible
Yeah, it's
task.
got to be nearly impossible, right?
Exactly, fit the nail on the head. And it all boils down to this really important difference between interpolation and extrapolation.
Okay, interpolation, extrapolation. Go on. Right. So when you're interpolating, you're basically working within the data you already have. You're connecting the dots, making these, sort of educated guesses based on the information you've got.
Kind of like those connect the dots puzzles we used to do as kids.
Exactly. Except instead of a cute little picture, we're trying to make sense of the stock market or the tides.
Exactly, yeah. Much less cute and way more stressful.
Right. But extrapolation, that's where we start getting into dangerous territory. That's when you're going beyond the data you have. You're trying to extend that pattern out into the unknown. And as that wave experiment showed, that's where even super sophisticated models, they can really stumble.
That makes a lot of sense. So it's not enough to just, like, throw a bunch of data at a model and just cross our fingers and hope for the best. We need to really understand the limitations of these tools.
Absolutely. We can't get overconfident. And I think one of the biggest takeaways here is that we should never, ever train a model on future data. Like, it needs to learn how to predict the future, not just memorize it.
Otherwise, it's just cheating.
Yeah, essentially. We're setting it up to fail when it actually encounters something new.
Okay, so where does this leave us? I feel like we've covered so much ground today, from trying to predict the stock market to finishing each other's sentences. It seems like sequence modeling has this incredible potential, but it's definitely not like a crystal ball or anything.
It's a powerful tool, absolutely, but like any tool it has, it has its strengths and it has its weaknesses. Understanding the limitations, I think that's the key to using it effectively.
And that's what makes it so fascinating, right? It's constantly evolving. There's always more to learn.
Absolutely. And, it makes you wonder, if past data isn't always enough for us to make those really reliable long-term predictions, what else could we use?
That's a great question. What other information could we give these models?
Right. What are the factors, maybe beyond the sequence itself that might hold the key to even better predictions?
That's something to think about. There you have it, everyone. Another deep dive. This time into the fascinating and sometimes surprising world of sequences.
Thanks for having me.
And until next time, keep those brains buzzing.